Hello, everyone. I'm Yang Wen. I'm very glad to report our work. The topic of my report was Multi-Stream Fusion Network for Multi-Distortion Image Super Resolution. The authors are Yang Wen, Bin Sheng, Lei Bai, Jinmin Kim, Ping Li, Yuping Zhu, Xiangai He, and Xun Zhu. In computer vision, capturing high-quality high-resolution images has attracted great attention from academia and the industry community. However, in limited hardware conditions, small prime lenses, consumer sensors, especially mobile devices, there are practical difficulties in obtaining such high-quality high-resolution images. The limitations mainly arise in three aspects. Firstly, the image acquired directly by the image sensor is usually noisy. In particular, the larger the pixel density of the sensor, the more obvious the noise. Secondly, most of the lenses used in mobile devices are fixed lenses with short focal length, which not only brings difficulties to remote object imaging but also limits the resolution of the image. Thirdly, the captured image is inevitably blurry due to camera shake or relative motion between the object and the camera. Figure 1 shows the degradation of image quality caused by different factors. In reality, image quality is always affected by various factors. As shown in Figure 1a, is the image quality degradation caused by noise pollution. B, is the blurry distortion caused by target motion. C, is the degradation of image quality caused by the defect of some image contents. D, is the image sharpness reduction caused by haze. E, low target resolution caused by shooting distance, etc. F, is the problem of decreased image sharpness caused by rainy days. For previous image recovery studies, such as denoising, deblurring and super resolution tasks, are all processed separately to break through the above hardware limitations. Firstly, super resolution aims to recover a high-resolution image from a low-resolution one. Convolutional neural network, CNN, based SR methods have shown incomparable superior performance compared with the traditional methods. For instance, SR-CNN pioneered the application of convolutional neural network to image super resolution. However, when the input LR image is polluted by noise and blur simultaneously, the enhancement of the texture and detail of the image using SR algorithm will cause the blur and artifacts amplification. Even if the input image contains slight noise or blurring, minor problems will be magnified. Secondly, image deblurring is one of the image restoration tasks to solve the effect of blurring on image quality. For instance, Zhu et al. Propose an end-to-end CNN model which includes two subnetworks to recover the latent sharp image. Then, deblur GAN, SR and GAN, Cycle GAN and others generative adversarial network are widely used in blind image motion deblurring. However, these existing methods can only roughly remove the blur in the image, but cannot simultaneously remove the noise and improve the spatial resolution of the image. Thirdly, image denoising is the process of reducing noise in a digital image. Classical denoising methods such as BM3D is based on priori knowledge of non-local self-similarity. Recently, CNN-based denoising methods have shown a relatively satisfactory performance. However, these existing methods can only deal with noise but cannot remove the blur and enlarge the spatial resolution. Figure 5 shows the image quality degradation caused by different factors. Deblurring, denoising and super resolution are important image recovery tasks that are committed to improving image quality. Despite the rapid development of deep learning and vast studies on improving image quality have been proposed, the most existing recovery solutions simply deal with quality degradation caused by a single distortion factor, such as SR focusing on improving spatial resolution. Very little work has been done to analyze the interaction and characteristics of the deblurring, denoising and SR mixing problems, how to reconstruct a low-resolution image with blur and noise into a sharp image is still an urgent problem to be solved. To overcome the existing limitations and meet the practical needs, it is urgent to propose a method to restore the low-resolution image with blur and noise to the clear high-resolution image simultaneously. The motivation of our work is twofold. Firstly, since the formulas and targets for denoising, deblurring and SR are different, for example, deblurring and SR aim to improve the high-frequency details while denoising may cause blurring and the removal of image noise. It is very important to determine the sequence of reconstruction tasks for multi-distortion recovery network. Secondly, since simply combining 2 or 3 tasks can often result in serious performance degradation, such as introducing new artifacts and obscuring, a direct and effective multi-distortion image recovery method is very important. We summarize the main contributions. Firstly, we verify the effects of different reconstruction sequences on the multi-distortion restoration task and adopt a progressive multi-stream fusion model for multi-distortion images. Secondly, we gradually fuse relevant recovery information from the denoise and deblurring branches into the super resolution network by the proposed fusion module. Thirdly, we use the residual attention module to effectively extract additional reconstruction information from the auxiliary branches. Vast experiments demonstrate the superiority of our method in solving the multi-distortion image recovery problem. The framework of our proposed multi-stream fusion network is shown in Fig.6. The proposed method includes deblurring branch, denoising branch and the trunk super resolution recovery branch. The input of our method is the low resolution image contaminated by both noise and motion blur. The deblurring branch is to recover either potential low resolution deblurred image and integrate the deblurring features FB directly into the super resolution recovery branch. Similarly, the denoising branch removes the noise and fuses the denoising features FN into the SR recovery branch. The trunk super resolution recovery branch gradually integrates the FN from denoising branch and FB from deblurring branch into the super resolution recovery process according to the multiple reconstruction execution order, firstly denoising and then deblurring, so as to not only amplify the spatial resolution, but also handle the motion blur and noise simultaneously. Besides, we use Fusion module to enhance the fusion of effective contextual information and promote the restoration of multi-distortion images. Since the input image is polluted by many distortion factors and various distortion reconstruction tasks interact with each other, we theoretically analyze and experimentally verify the effect of different reconstruction task sequences on the overall performance to determine the optimal sequence of multi-stream fusion. Figure 7 is the framework of the proposed fusion module. FLRBN denotes the input LR image with noise and motion blur. The input feature FLRBN, the SR feature FS1 and the denoising feature FN are first concatenated and then go through a series of convolutions to get the weight map. FC1 is the weighted fusion feature obtained by the fusion module and used as the partial input of the SR recovery branch. Figure 8 is the training data generation pipeline. We subsampled and added noise to the original GoPro dataset in turn. To verify the recovery performance of our method on the multi-distortion images, low-resolution images with blur and noise, we use the classical GoPro dataset which contains total 200 pairs of high-resolution blurry and sharp images for training and testing. In our experiments, we firstly do data augmentation by resizing each HR image pair with 3 random scales and cropping each data pair into 256 × 256 blocks with a step of 128. We then obtain the pairs of low-resolution blurry patches and low-resolution sharp patches by downsampling the responding high-resolution pairs images. To constrain the denoising branch and deblurring branch to further promote the acquisition of high-quality HR reconstructed images, we finally generate the low-resolution noisy and the low-resolution degraded image with blur and noise by adding Gaussian noise. Totally, we get 107,584 stacks for training and testing. Then, we will present the results of our experiments. We implement different processing pipes and test with SR factor of 4 and noise level of 25 on our generated training dataset. Table 1 shows the quantitative comparison of different pipelines on the denoising, deblurring and SR mixture distortion problem. It shows that executing DN first or DB first yields nearly the same performance, if the denoising is not performed fiercely. The performance of subsequent tasks will decline sharply due to the artifacts and error accumulation. To prove the effectiveness of our method for handling the problem of multi-distortion image recovery, we have done vast qualitative and quantitative experiments with several competing methods. Table 2 shows the comparative results of quantitative indicators. The end-to-end recovery method contains the same reconstruction network module as our method, which directly rebuilds the input low-resolution blurry and noisy image into the HR sharp image. Different from our method, it does not adopt the multi-branch fusion. In the experiment, we use the same training data to retrain the end-to-end recovery method to ensure the fairness of the comparative experiment. From Table 2, we can see that our PS and our NSIM are respectively ahead of other optimal methods. Obviously, our method shows superior performance both compared to end-to-end recovery method and the cascading recovery method. Figure 9 shows the qualitative comparison of several classical recovery methods with our method. It clearly shows that our method achieves more sharp high-resolution recovery images with rich detail and structure, especially in the colored border area. Finally, we conclude our work. We propose an effective deep residual gate fusion network for depth map super resolution. Experimental results have shown that our method achieves state-of-the-art performance. We present a new color map guidance strategy, attention mechanism and multi-scale fusion method, which can effectively solve the misalignment problem, artifact problem and texture migration problem in depth map super resolution. Our future work will explore images other than high-resolution color images as reference images for depth map super resolution and consider the task of super resolution for color image and depth image simultaneously. Thank you for your attention.